All right, good morning. Today I'm reviewing chapter 8.2 and 8.3, and I'm working harder examples so that way you have a little bit more variety to look at when working these problems. Okay, we're solving for x, so that means we got to get this x by itself. So the first step is we want to have the same basis. So the first thing I notice is that this is in a fraction. So I need to bring 81 to the numerator. And when I do that, we've learned that when we bring anything from the numerator to the denominator or vice versa, the sign of the exponent changes. So that's how I got 81 to the -1. Now, what does 9 and 81 have in common? How can I change 81 to have a base of 9? Well, we know that 81 is 9 squared. So I have 9 squared. There's my next step. Now, with exponents, we've also learned that when we have an exponent raised to a power, we multiply. So I have 9x to the -1 equals 9 to the -2. I have the same bases, so I'm going to drop my bases. So I'm going to come up here. So I have x minus 1 equals -2. So I'm solving for x. So x equals -1. Because when I bring -1 over, the sign changes. There's my answer to number 1. Okay. Next example. We have 1 over 9, 3x plus 5, is greater than 1 over 243, x minus 6. Now, all right, here we go. Sorry, my bad. I was trying to get my thoughts together on this. I have 9. I'm going to bring this up. So I have 9 to the -1 is 3x plus 5 is greater or equal. Now, 243 I'm going to bring up, and I'm going to have 243 to the -1, x minus 6. Okay, now what does 9 and 243 have in common? Well, I can change both of these to a base of 3. So 9 is 3 squared, which is going to be 3 to the -2. 3x plus 5 is greater. 243 is 3 to the 5th. I went ahead and figured that out for you. So you have 3 to the -5, x minus 6. Now, we're back to where we were up here. We got to multiply our exponents. And in one quick motion, I'm going to go ahead and I have 3 to the -6x minus 10 is greater or equal to 3 to the -5x plus 30. Okay, so here my bases can drop. So I have -6x minus 10 is greater or equal to -5x plus 30. So I'm going to bring -5x over here. So it becomes +5x. That gives me -1x. I'm going to bring 10 over here. So that's going to give me 40 because my sign changes. So I add 10. Now, I'm dividing by -1. So when you divide by -1 with an inequality, what happens to my sign? That's right, it changes. So x is now going to be less than -40. There's my answer. So don't forget about that sign changing because you divided by a negative number. All right, that was 8.2. Now, with 8.3, we learned the other day that we can change from exponential to log form, and it's just writing it in a different way. So I'm going to change 9 to the -1 equals 1/9 to log form. So that means I'm going to add log. What is my base? My base is 9, so it goes right there. My answer is 1/9 equals -1. My exponent goes on the other side. So this would be my answer. Okay, for the next one. Here's my base, my exponent, my answer. So I have log a base 25 of 125 equals 3 over 2. So there's my conversion from exponential to logarithmic form. All right, last couple examples. We're going to evaluate. That means when it's evaluate, we're getting a number, a numerical answer. So I have log base of 3 of 1/9. I don't know what my exponent is, so I'm going to put equals x. So I need to change it to exponential form. So what is my base? 3. What's my exponent? X. What's my answer? 1/9. Now I'm back to this type of a problem up here. I need to bring 9 to the top. So I have 3x equals 9 to the negative 1. Gotta have the same base. So 3x equals 3 squared to the negative 1, which is 2 times negative 1. So I have x equals negative, let me change that to a 3. Negative 2. Because my bases drop and I multiplied. So x equals negative 2. Okay? Here, I'm solving, so I have equals x. So 121 is my base, x is my exponent, 11 is my answer. I need to make 121 have a base of 11. Well, we really know that 121 is really 11 squared. So I have 2x equals, notice that I have an exponent 1. It's never written there, but it's understood to be there. So because I'm solving for x, I got to put that there. Equals 1, so x equals 1/2. There's my answer, okay? Here's some good examples of some hard problems. So if you have any questions, don't hesitate to email me or ask me whenever we do live video, okay? Thank you. Bye-bye.